Hello, my name is Jack, and I hear you're in the market for a nuclear warhead. Let me show you your options. Please come in. Before we begin, however, I must tell you of the fuel source for your warhead and its mechanics, just so that you know that you can make the most physically sound option. There are two types of fuel sources: uranium-235 and plutonium-239. Uranium-235 is rare in nature, so to use it as a fuel, scientists have to enrich the natural uranium-238. In other words, separating and concentrating the uranium-235 from the other types of uraniums that would not explode. It emits very little passive radiation, making it safer to store and much harder for your adversaries to detect. Importantly, uranium-235 is highly stable and reliable. As a result, it is very simple to use to design a weapon with, and scientists can be highly confident that it will work without needing complex testing. However, you will need a lot of material for a good explosion. We're talking like 15 to 50 kilograms of enriched uranium-235. So, the warhead will most likely be bulky. Plutonium-239 is a man-made element created in nuclear reactors by bombarding uranium-238 with neutrons. It is super light and compact, just needing 5 to 10 kilograms for an explosion, and is way more efficient as it releases slightly more energy per atom and shoots out more neutrons when it splits, making the reaction faster and more powerful pound for pound. However, it's highly radioactive, as it constantly shoots harmful radiation in the form of gamma rays, making it dangerous to manufacture and easy for your adversaries to detect. It is also very volatile, so if you do not squeeze it together perfectly and at a mind-boggling speed, these neutrons will trigger explosions too early, causing a tiny weak pop that just breaks the bomb apart and scatters dangerous materials all around. Uranium-235 is naturally the only economic start point for any nuclear weapons program. Because plutonium-239 is man-made, you cannot create it without first having a nuclear reactor fueled by uranium-235. It might be worth our time to look at the science behind the warhead, just so that you know how your future purchase will work. All nuclear activity depends on nuclear fission, which is the physical act of a heavy atomic nucleus, the atom center, splitting into two smaller pieces, releasing a few extra neutrons. The nuclear material used must be fissile. If its atoms are highly likely to split apart when hit by neutrons at any speed, which is what allows it to keep a continuous chain reaction going. What you want to achieve for a warhead is a nuclear fission reaction, which is the highly energetic process that happens during the splits, converting stored nuclear energy into a massive release of heat and kinetic energy in the form of movement. The efficiency and the maximum explosion yield completely depends on what sort of warhead model you want to use. So let's start off with the most vintage and simple model, the gun type model. Before we begin, here is an ingredient list. Now, the gun type model is basically a high-tech cannon built inside a bomb casing, and is the easiest and most straightforward way to design an atomic bomb. It is the little boy bomb dropped on Hiroshima in 1945. Inside the bomb, there's literally an artillery gun barrel. On one end sits a hollow cylinder of nuclear fuel, known as a projectile, and at the other end sits a solid cylinder of fuel, known as the target. When the bomb's triggered, regular gunpowder-like explosives, called carbide, is ignited behind the projectile. This shoots the projectile down the barrel at speeds of 1,000 meters per second. The projectile slams directly into the target, instantly uniting them into one highly dense supercritical mass. Supercritical just means that you have packed enough nuclear fuel together so close that a runaway chain reaction of splitting atoms can take place. the violent crash breaks open a tiny capsule at the center called an initiator. This initiator mixes the two elements, often polonium and beryllium, to release a quick burst of neutrons, which acts like a match to ignite a nuclear explosion. For reference, since I happen to find this image in my files, this is what the inside of a gun-type bomb realistically would look like. If you explode this sort of bomb, it will yield about 15 kilotons of regular TNT explosives detonating all at once, enough to wipe out all of New York's Central Park. If you want something more complex with more of a bang, then the implosion type model is for you. Here is a quick ingredient list in case you want to make this, and as you may notice, this time we're using plutonium instead of uranium. The implosion type warhead uses a sphere of fuel and crushes it from all sides at once. At the very center sits a solid or hollow sphere of nuclear fuel, which is about the size of a medium orange. This core, surrounded by heavy metal tampers and a giant spherical shell of high explosives arranged in hexagons or pentagons, like a soccer ball. These explosives act like lens made of fast-burning and slow-burning chemicals, such as composite B and baratol. When ignited, they wrap the blast wave so that it focuses perfectly inward as a uniform shrinking sphere of pressure. The inward traveling shockwave slams into the heavy metal tamper, which helps push the force inwards to compress the nuclear core. At this instant, it squeezes the dense metal core into half its original volume. And at that exact microsecond of maximum compression, a tiny initiator at the center is crushed, releasing a burst of neutrons to kickstart a runaway atomic chain reaction leading to an explosion. If an implosion of this bomb was detonated over Trafalgar Square in London, the total area of destruction would stretch from Buckingham Palace in the west, past the British Museum in the north, and across the River Thames to the London Eye. It would probably look something like this. Now we are entering the mid-range of the showroom, known as the advanced fission weapons. However, this video is already too long, so I'll show you them in the next video. Stay tuned and have a good day.